How many of us here do code review in our day-to-day job? How many of us here use IntelliJ IDEA? Everybody in the team will not have the same level of awareness of what is in a particular code base. The benefit that me I have seen in my day-to-day work is hidden edge cases that people's eye cannot easily see. You will do it better, you will do it smarter, and you will do it faster, and your team will do it more consistently. My name is Sunday, and I work for RightMove. And in my day-to-day job, I'm very passionate about using AI code assistants, especially Copilot and things like that. And I'm one of those that is evangelizing and promoting it within the company. So before I start talking about what I'm here to present this evening, by the way, the topic is how we can use AI to modernize one of the things that we do in a day-to-day job. So I'm going to ask 3 questions. Number 1 is this: how many of us here do code review in our day-to-day job? Can I show a raise of hand? Good. A good number of us here do. How many of us in this audience do code review from the ID that we use rather than on the code repository, GitLab or okay, we have 2, 3, 4. Good. How many of us here use IntelliJ IDEA? Good number, of course. Very good. So what I'm hoping to achieve this evening is that I will show you how you can use your IDE and AI to do code review for any code that you want to do. I'm hoping that you take something away that will help you to do code review when you go back to your day-to-day job. So number 1, let's start with the problem statement. Most of the time, or in some instances, when we get a PR or an MR, we often don't know all the changes that are, we often don't have the complete context of what the change is all about. Sometimes we are called upon to do code review for someone from another team. Sometimes we are called upon to do code review for which we have not seen the ticket. If you run microservices and you have multi-team, some people from other teams will make changes in your code base and send you the code review, and you won't have enough context of what the changes is all about. So that's number 1 problem. Number 2, on many occasions, people will wait on us to be able to complete the code review, meaning that the turnaround time sometimes is not what we want. It can take some time, a considerable amount of time to complete a code review. So in that case now, the problem now is response time for human code review can be slow. And another problem that is also very common is that as humans, when we take an MR and we are going through it with our own naked eye, it is very common to miss edge cases or hard or difficult to find bugs, especially if you don't run the code before you do the code review. So these are 3 key problems that are common with code review that AI can help us to be able to solve. So I'm just going to go straight into the benefit of using AI to do code review. Number 1, AI can take a look at the set of changes in an MR and then give you a summary of the changes that are in the MR, meaning that you can have a summarized context of the change that is in the MR. And sometimes when I just look at those changes that are in the MR, I'll then go and look at the ticket and then compare what is in the ticket with what is in the summary of the MR. And sometimes that will be the end of the MR. If the summary of the changes in the MR does not conform with what the ticket is saying. But the benefit of it here is that when you look at the summarized context of what is in the change, it gives an idea of what is in the change set even before you start looking at it. If you don't have something like that, you need to go from the beginning of all the code changes from the beginning to the end before you can have an idea of the changes that are in the MR. A second benefit is that AI can help you to catch hidden edge cases that your human eye may not be able to see. No checks, boundary conditions, security risk, performance improvement, organizational policy or team-specific policy. Some of us works in organizations where engineering handbook about how we should write code is like maybe 1,000 pages. And it could be organizations that have multiple teams. Each teams have their own team-specific policy as well too. As humans, when you are looking through an MR, you might not be able to remember everything in your organizational policy. You might not be able to remember everything in your team policy. AI can bring all this context together and help you to see where an MR does not meet your organizational policy and where it does not meet your team specific policy. We'll talk about a few of those. And then another one is speed and consistency of doing code review. If you work in a team, usually everybody in the team will not have the same skill set. Everybody in the team will not have the same level of experience. Everybody in the team will not have the same level of awareness of what is in a particular code base. Meaning that if everybody in the team is reviewing an MR for a particular repo, everybody is going to provide different review for an MR. With AI can help with doing a review of an MR in a consistent way, so that all of us can be empowered to do code review in a consistent way, and then the speed of doing it too will also be improved. Now I want to talk about a case study, and the case study I'm going to talk about is about GitHub Copilot. And I have another question: how many of us here use GitHub Copilot within our IDE? Good number of us. GitHub Copilot is a code assistant. You can use it to generate code. You can use it to ask questions. You can use it to do multiple edits. And at the same time too, with the agent mode, you can use it to carry out on an autonomous task on your code base. One application of GitHub Copilot, and most of the LLM in particular, is using it to do code review. And these are some of the things that it has that enables that code review to be able to take place. GitHub Copilot has something that is called instruction files. And it also has something that is called repeatable prompt files. Instruction files are a set of instructions that you give to GitHub Copilot to help it to have a context of what you want to do, so that when it is carrying out its tasks, it will do it according to what you want and the way in which you want it. And some of them can be organization-wide, and some of them can be team or a repo specific. Most of us here will have, wherever we work, we have things like development standards, engineering handbook, engineering manual that contains so many things about what we want, about what we do. So those company-wide standards, GitHub Copilot has a way of looking at an instruction files that are organization-wide, meaning that some standards is expected across all the organizations. And then for each specific repo, some standards may differ. We'll see some of those. We'll see some of those examples. If you run microservice, for example, and you are in a polyglot environment where you have Java, you have Kotlin, you have front end, you have React, you have Vue, where you might have one organizational standard across all repos, each of those repos could have their own each individual set of instructions. Those are repo specific instructions. So GitHub Copilot has a way of differentiating such one. And GitHub Copilot also has what is called reusable prompt file. We'll get to some of this specific. If you are using ChatGPT, for example, you type in you type your prompt and you get your response back. GitHub Copilot has a way of saving those prompts, especially the prompts that you use on a repeatable basis. It will save it, keep it somewhere, and so next time you want to use it, you just use it straight away without typing typing the prompt. So reusable prompt files are standardized prompts to consistently detect customer security, performance, and policy issues in your. What I'm going to do with GitHub Copilot here is not only specific to GitHub Copilot. You can adapt other AI coding assistance tools to do the same thing. Windsurf or Cursor, all those things can be adapted to do code review. So they all have similar offering. But I'm going to provide specific example of how these tools can fit into a code review workflow. This is what I have done. I've gone to GitHub and I have cloned a repo, and that repo is called Java Design Patterns. How many of us here do Java? Oh, good. A few number of us. Nice. Yeah. So Java Design Pattern is just a repo that contains that contains a description of all the patterns that we have in Java. So someone have gone there and created an MR and added a new design pattern. That new design pattern is called polling. Where is it? It's called polling publisher. That's the MR. So I've cloned this repo. So that's the branch, issue 2673. As you can see here, that's the branch. I'm not on master. Give me the set of changes with master and put it in change set.d. They will produce a file for me, and that file is here. That's the set of all the changes that are in this MR. This is IntelliJ, settings. You go to tools. If you add I have the GitHub Copilot plugin. Sorry, I didn't talk about that. Copilot is subscription based. You need to be subscribed, and you need a plugin, and you need to add a plugin to ID, and you then have this. You see, custom instructions. It has Copilot instructions. There's a workspace one, and there's a global one. The global one is where you put things like your organizational policy. It can be things that are in your engineering handbook, manual, development standard, markdown files. You can put them all together and put them in a markdown file. The instruction file usually a markdown file. So you just open this one. That's the global one, and this is. I just put some example global instruction files here. So this file defines company-wide coding and review guidelines for GitHub Copilot. General guideline. Always follow Java 17 language features unless explicitly restricted. And the last one, always provide Java document for public classes, method, and API. Things that you care about, things that you want your code to be specific about, you just put all of them in your instruction file. Spring Boot guidelines. If you use Spring Boot 3.x conventions. Always use our configuration properties, default to SLF for J, security best practices, and for ATP only. All the things that you care about. If you're on GKE, always create Docker file using non-root users, review workflow for Copilot. The things that you care about, all those things that is in your organization care about, just put them in the global GitHub Copilot instruction file. Now I'm going to go back and go to the repo specific one, which is I intelligently call it workspace. This is the workspace one. And the workspace one is usually the location is within the repo itself in a folder called .github Copilot instructions. It is this one here. So this one is Copilot instruction file team policy. Not necessarily only team policy, it could be repo policy, because your team may have multiple repo, and you could have different policy for each of those repo. Say code style. Always use tab for indentation. And then for developers, people fight about whether you use tabs or whether you use spaces. If your team agree and say we want to use tab, put it there. Line length, 120 characters minimum. Place braces on the same line. Use meaningful variable method name, blah, blah, blah. All the things that you care about that are specific to the team and that are not necessarily in the engineering handbook. You put them in the repo, specific one. Now we are done with organizational-wide instruction files, and we are done with the repo specific file. Let's now move into the act of doing code review itself. You can create a repeatable code review prompt file. Those ones are usually in a folder inside .github called code review. I just call this one code-review.prompt. So the repeatable prompt file has .prompt.md. I'll open it like this. At the top is a declarative. I'm just telling GitHub Copilot what this is all about. In the mode that this instruction is useful only in the agent mode. Copilot has 3 modes: the ask mode, the edit mode, and also the agent mode. I'll demonstrate those shortly. Then the tools that you will use. If you are using an agent mode, the tools that you will use. Code base, which is the entire of the code. You can do git diff. You can use run shell command. I can also use run git command as well. So, and just give it a description. And here's the bit about the art of doing code review itself. So say at the top, it just says, okay, sorry, let me make it easy to read here. It says that the git diff in this feature branch against the master branch it was branched from has been extracted into change set.d, which I've done. please co-review the code changes and provide feedback on the following areas. So number one, summary of changes. That's it. You are asking Copilot to please give you a summary of all the changes. That is the context of all the changes that are in the ML. Provide a brief summary of the changes made in the ML, mentioning significant architectural or design changes. Sometimes you have a code base, people are making changes outside the team. You say it, please don't change the architecture. Just make sure you follow exactly what is there. You can instruct Copilot to let you know when a change in the architecture is being made. Code quality and readability, maintainability. Review the changes for readability and clarity. Identify any functions that are overly complex or lengthy. Testing and validation test. Ensure that the test cover edge cases and error handling. Use of best practices, performance and efficiency consideration, security vulnerabilities and privacy concerns. Identify any potential security vulnerabilities in the code. Suggest improvement to enhance security and privacy. Suggestions for improvement. These are just the things that I put here. You can think about the things that you care about when you are doing code review, either within your team or whatever, and just put all of them here. And at the end, please provide your feedback in a structured format with sections for each of the above points. That is setting up Copilot to be able to help you to do code review. Now let's go. I have the change set. I have this. For GitHub Copilot, here it is. You can see this on. What that means is that file will be included in the context window of the LLM that you're going to choose to do the code review. Leave it on. This slash, you put a slash, you have a set of tags or things that you can run. This doesn't appear very well. Just say code review. Let me close this. I'm going to just type I just add the first name of the prompt. Code review that's prompt. You could have multiple prompt files. When you want to execute it, just type the name before the prompt, just like this one here. Now, these are the mode. We're interested in the agent mode because we have said the code review will be done with the agent mode. And these are the LLMs that I have access to. There are three key ones, GPT, Gemini, and Cloudy that I usually use. GPT-5 is one of the most recent one. I will just choose that one. One that is also very capable for code review is Gemini 2.5 Pro. Cloudy 4, Cloudy 3.7, they are also all very capable, also very, very good. But I'm going to use GPT-5. And let's go. All right, so let's go through the things that it does. It did, that's a summary of changes. Say, added new multimodal pattern, introducing Kafka-based pub sub demonstration plus REST endpoint, add basic JUnit 5 test for application startup and simple repository service behavior. So that's a list, that's a summarized list of all the changes that is in there. Most of the time, I'll just stop here and then go and look at the Jira. Have you done all the work that is needed or not? Sometimes I just stop here, and sometimes, yes, if it makes sense to me, I will continue. And now start, code quality, readability, and maintainability. Assembly plugin misconfigured, main class values are hyphenated package name from this, blah, blah, blah. Kafka producer both declares field as final and annotate with auto wire is redundant. Pooling scheduler create new random each run should use ThreadLocalRandom. Quite, if you read through Tests do not cover controller, scheduler, Kafka flow, or error scenario. Data source service tests get all data relies on internal map, mutability, brittle. It gives you a lot of things that your eye might not be able to pick immediately. Some will be security concerns, some will be, in this section, it is code quality, readability, and maintainability. Next one is testing and validation. Only simple JUnit tests present. Team policy requires support. So if you go down, testing and validation, no test ensuring executor and data service, no test asserting configuration properties, use of best practices. It will list some of the things that are good about it. Performance and efficiency, it will list the things that are problematic with it. Security and privacy, based on what you have asked it to do, it will list all the problems that are there. Then, mind you, at the end of my instruction file, I have suggestions for improvement. Will then list all the things that it suggested. Fix assembly plugin value, add Spock test. Because in my instruction file, I said our team prefers Spock test over JUnit. In this ML, there's no Spock test there. It's now saying add Spock test. So you can then pick just one specific problem that is here, or the thing that really concerns you. This one is a slightly big amount, about 22 files or more than. If there are one that is small, I don't expect in some instances, your changes might not produce as many problems as this. You can pick the one that you want, and then within the IDE itself, if you are using GitHub, for example, and you have a GitHub plugin on your IntelliJ IDE, you can go to the change where the problem is. This one is here. Okay, so in conclusion, AI makes code review faster, smarter, and less fatiguing. Most importantly, the benefit that I have seen in my day-to-day work is hidden edge cases that people's eye cannot easily see production system. However, human oversight still remains very, very essential. The core thing is that best code review comes from AI plus human collaboration. If you do code review on yourself, yes, you could be good, but if you use AI to help you to do code review, you will do it better, you will do it smarter, and you will do it faster, and your team will do it more consistently. Now it's your turn. What question do you have?
Hi. Thanks for the talk. I might have missed it as part of the workspace context that you were setting out, but is that where you put in the requirement for the change? So obviously this change, the diff, is to perform a bug fix or some new functionality. Does that come from a bug of a force or a change? Is that fed in as well, so that it can do the review to justify that the change is meeting the requirement? And I was going to ask us, had you played with it at all and made some changes to the review where like there would be a subtle part of the requirement that was missing? Did it actually pick that up as part of that?
I think Copilot doesn't know what your exact requirements are, but it knows. Okay, if you put the requirement there, yes, you can compare the requirement against the changes in the code base to confirm if your requirement is met. Yes, if the requirements are there.